Greetings and welcome to the graphics class. Question number 9, isometric projections. A square slab of 40 mm side and 25 mm thickness is surmounted centrally by a cone of base diameter 32 mm and height 40 mm. Draw the isometric view of the combination of solids. Here the question is about the combination of a square slab and a cone. So when there is a combination, first of all we have to draw the symbol position as the combination. The question is to draw the isometric view. So there is no need of isometric scale. Straight away we can draw the symbol position using the actual dimensions. The square slab is of base edge 40 mm. The thickness is only 25, or normally we are saying it as height. Since it is a slab, it is only of thickness 25 mm. This is 25 and this is 40. Now inside this you are having a cone. So the base of the cone can be drawn inside the square itself. The diameter is 32. That means the radius is 16. Using 16 mm radius, we can draw the base of a cone. You can draw the base of a cone. Okay. Now you can draw the front view of the cone also. Again the height is 40. Using 40 mm as height, we are completing the cone. Now, you can keep the cone inside a box as usual. Normally, when we are drawing the isometric view of a cone, you are using a box. So, the box can be named as W, X, Y and Z. I am not at all naming any other parts because there is no need of such things. You can straight away draw that. So the diameter is 32, that also I am marking. Okay. So all the dimensions are here. All are with true dimensions. Now we are going to draw the isometric view. For drawing the isometric view, as usual you can have a horizontal line and draw the isometric axis which are inclined at 30 degree to that horizontal line, or which are mutually inclined at 120 degree. Okay. Initially we are going to draw the square slab. It is very easy, you know how to draw that. So we are going to draw the square slab. This is the square slab. So I am fixing this as one corner. From there, I can take 40 mm. From here, I am taking 40 mm. So, I am getting this as 1 point. From there, I am drawing the next part. Along this again, I am marking 40. After that, I am drawing another line which is parallel to this one. And I will get 40 mm here also. So this is the base, bottom base of the square slab. Already we have drawn the square prisms many times. Now the height is 25. So from here 25 mm you can measure. From all the corners you can take 25. So you can connect all this. Okay, you got that part. So the square slab is over, but we need the combination of solids. So next we have to draw the cone on top of this. For that, you can draw the diagonals initially. After drawing the diagonals, you have to keep this particular Wx along this in between these diagonals and which is parallel to this one. So the same dimension you have to take, that is 32. 32 will be one side of this. So that should be parallel to, I will take another pen. We can have another line which is parallel to this one and should be a length of 32. So by trial and error you will get that. Then if one side you get, after that the other parts you can complete easily. Okay. Now here you will get, okay, so inside this you will get the base of the cone. That is what we are going to draw next. How to draw the base? You know the 4 center method, isn't it? So we can have this as M1, M2, M3 and M4. Using this, you will find out the 4 centers through which you have to draw. Okay, this one. So now you got the base of the cone. You got the base of the cone. The rest of the part we have to draw. For that, you know the height is 40. So from the center, this is the center of the cone. From the center, you can take the axis as 40 mm length. From there, say this is point O. So from there, you can have a connection to the extreme ends. So now the cone is on top of the square slab. Finally, we have to complete the visibility. How to check the visibility? All the outer edges are visible. So let us check which are the outer edges. So this is an outer edge. This is another outer edge. This part is outer edge. So from here to here it is an outer edge. This is also an outer edge. Okay, and from here to so this much portion is the outer edge. Okay, now the remaining visibility. So you are keeping the solid in this manner. Whatever be on top of this particular surface will be visible. So the outer portion of the cone will be visible. Outer portion of the cone will be visible. The other part will be invisible because that will be hidden by this particular surface. Now, this top base of the square slab is also visible because if you keep it like this portion is nearer to the observer. One more edge is visible. This one is visible because it is very close to the observer. So that is also visible. Okay. So now we can conclude. we have started with the simple position of the square slab. Initially we have drawn that. Then we have kept the cone on top of the square slab with the given dimensions. And then we have drawn the front view also. After that, using the dimensions, using the actual dimensions, because it is an isometric view. Using the actual dimensions, we have gone for the isometric view. So initially we have drawn the isometric view of the square slab. Then we have found where to draw the isometric view of the cone, that is just above the top surface. Keeping that on top surface and the centers as the same, we have started drawing the cone. Then we have found out which are the edges visible. Thus we got the isometric view of the combination of square slab and the cone. Now you can practice this.